Hello, my name's Tony J from Eiger Design. This video will show a simple demo of the J-Testr with ATEasy software. This demo is not intended to be a lesson on ATEasy itself, however will show how quickly a test can be set up. The test that will be constructed will test the efficiency of a power supply on board a UUT. As you can see in the block diagram, the UUT has a 12 volt in, a 3.3 volt out power supply. The J-Testr will provide a supply peripheral card which will supply the input voltage and has a load peripheral card that provides the load on the output. As you can see from the formula below, efficiency equals power out divided by power in times by 100. This demo will show how quickly a power supply can be set up and how easily current and voltage measurements can be taken. This is the same for the electronic load, which also has current and voltage measurement, and instead of an adjustable supply, an adjustable load. Obviously this is only a small proportion of what the J-Testr has to offer. There are other cards available such as ADC, DAC, timer, I/O, both high voltage and low voltage, plus many other functions. Okay, let's get started with the test. So first of all, we will start a new project. We will call the project efficiency and find a suitable location for this to be stored. Okay, so up here we now have our test, we have programs and we have systems. So at the moment we have no system set up, so we will add a new system. This system will obviously be a J-Testr system, and the J-Testr system will require some drivers to be loaded. So if we click on drivers, we will now insert the drivers. So it takes us immediately to the standard driver location. However, we will go to our specific locations where the J-Testr drivers are stored. And here we can see all of the drivers that are available for the J-Testr system. So as per usual, we always need the system. That's the J-Testr system, which runs the fans, the bus, and everything required for the J-Testr system to function. So we will now insert another driver. So here we will pick the low voltage supply card. And finally the load card driver. So while we're here, you see they come with some standard names. We can change those names to something more convenient for coding. So we'll call the system sys. Supply we will call PSU. And the load we will just call eLoad. Okay, so that is now the system. We can open it up here. So we see we have one system, and the system has loaded a system, a power supply, an electronic load. So if we now go up to programs, currently we have no programs, so we add a new program. So we'll just expand that out. So the program has tests. So at the moment we need to have a test, so we will call this efficiency tests, and then we actually have to have a test itself. We will just call this efficiency for want of a better name. Now if I open that up, this is now where we place our code. So as I went through that fairly quickly, I will just summarize. First of all, we set up a system. That's a test system. This is the way the ATEasy software works. And we added some drivers specifically for the J-Testr. And then we came up, we added a program, and we added a test group and called efficiency tests. and then one of the tests specifically we called efficiency. Okay, the first thing we must do is initialize all of the drivers. So we will first of all initialize the system. So if we type sys, what we notice that the sys actually then gives you all of the options available for that driver. So in this particular case we just want to initialize. So here we are, we just double click there, or we can type it out, whichever you prefer, and we've initialized the system. Next we will initialize the power supply unit. You can see again we go down, there's a function called initialize. So we click on the initialize and it is prompting us to give it a slot where that card is fitted within the J-Testr system. So the supply card is fitted in, I believe, slot 7. And then we will go to the electronic load. Oops, electronic load, smaller case. And again, initialize. Now the electronic load, I believe, is on slot 0 within this test setup. And we have now initialized all the J-Testr cards. Okay, I apologize, I just took a moment out there just to check the slots. Actually the power supply is in slot 0 and the electronic load is in slot 7. I just got those the wrong way around. So after initialization, it's always best when you're starting a J-Testr test is to do a nice clean reset. So this is part of the system, so we can type sys and we get all the options again. This is context sensitive, so we can go down, we can see there's a group set called reset and one of the selections is activate. So that line has activated the reset on the J-Testr. So we will do another one, reset, deactivate. So that has now a clean reset to the J-Testr system. As you can see, this is very easy because every time we type in the driver name we get all of the options that are available, and if we go to one of those options, if there's further options available, they are also listed. So now we will set up the power supply. So now let's set up the PSU. So if we say PSU and do space, you see we get many selections because there's not just power functions on board the power supply card, there's others. But we will go down, and the first thing we will make use of the protection features for the power supply card. So we will go to protection, we will go to set, and we will set the over voltage first. So if we go back to that block diagram, one thing I didn't make clear earlier is that the supply card has two supplies, supply A, supply B, and we will be using supply A for this test, and we will be using load A on the load card. Again, there is two loads, load A and load B on the load peripheral card. I forgot to mention that earlier, so we'll just close that down. So what you saw when this over voltage propped up, over voltage in millivolts, you saw we got a list of supply A, supply B, or supply both. That's both supplies. We will just set up supply A. So we will set up supply A for 12.5 volts. That's 12,500 millivolts, because this is obviously pre-appended with millivolts. So that set up the overvolt protection. So we will again type the name of the driver. We want the protection, and we will set, and this time we want to set the overcurrent in milliamps. So again, you can see it's just prompting us all of the potential options for this particular function we are accessing. So again, we want supply A. And we will set this up. I did some approximate calculations before this video that 2 amps should be sufficient. So anything above 2 amps will trip the overcurrents. Now finally, we want to actually set the voltage that we are going to send to the UUT power supply. So we will do PSU, and we will go down to the supply, and we will set. You see we have command, delay, ramp rate. We're not interested in those. They're very these particular 2, delay and ramp rate, are advanced functions. However, we are interested in setting the voltage in millivolts. So again, which supply it starts in, so we can do A, B or both, but we just want to do A, and we will set that to 12 volts. Nice and simple. So now we have the supply set up. Let's set up the load, and here we can, again, if we look here, the driver's called eLoad. So we type in eLoad and we get all the options. So we will set up the protection first. I won't go too much into detail, but we've set up the overpower voltage. That is basically a threshold that it says if the voltage goes any higher than this, it will consider that as an overpower risk. So we will say overpower and load A. Again, as per the block diagram, the load is on the load A channel, not the load B channel. And as the supply outputs 3.3, we will set the something higher. Let's set 4 volts. Now that's all the protection set up. I need to go ahead and set up the actual load, eLoad load set, and we will set up the current in milliamps. This is very similar to the supply where we set up the voltage, but here we're setting up the current. And again, we get 2 options. We've got the load A, and we will set the load A with 6 amps. So that is actually, for this supply, full current. So now we can go ahead and actually turn on the supplies. So basically, just quickly do an overview. Up here we set the protection features of the power supply, and here we set the actual voltage the power supply is going to be set to. Here we set the protection features of the load, and here we set the current for the load. That's actually the load that will be applied to the UUT power supply. Okay, now we will turn on the supplies. So we go to the PSU first, and we will go down to the supply. You'll notice when we did set, there was such a thing called command. You'll see this all in the instruction for the supply card. So we go to the command. So for supply A, we get all of these options. We can kill the supply, no action, turn off by global trigger, turn off now, turn on by global trigger, or turn on now. We just want to turn it on now. All of these features are clear in the instructions, but we're just going to command the supply A to turn on immediately. And then we will go to the electronic load and do a similar line. So here we go, electronic load, set command A, and we will turn load on now. Okay, so there we go. So now at this particular point all the supplies are on, so we really need to give it a settle time. So let's give it, say, 1 second. So in ATEasy, the sleep command is actually in milliseconds. I'll just go back there. Once you saw with brackets, you can see here that it's telling you that it's in milliseconds and that it's a value of long. Okay, That's very ATEasy specific. Again, this tutorial is not about ATEasy, just how easy it is to set up a test. So we will set up 1 second, 1,000 milliseconds for everything to settle down. Okay, so now we have the supplies on, we need to go and get some measurements. So get measurements. We're going to need some variables, so it's a good point to go and set up some variables. In ATEasy, we have to go here to variables, and then we can add variables for the test. So we're going to need a few variables in this system to measure the efficiency in this test, sorry, not system. So one of them is going to be the voltage in. So we call that V in, and then we will have an I in, that's the current input, and then a V out, followed by an I out. We add another, sorry I'm doing this quickly, we have limited time on the video, so we do P in, that's for the power input, and P out for the power output, and I believe that's all we're going to need. So just to overview, we've set up some variables, they're all of type long. Okay, you can have floats and etc., but in this situation we will be fine with a long. And we've got voltage in, voltage out, current in, current out, and power in, power out. So that's everything we should need to set up this efficiency test. So back to the test itself, we will get the measurements. So we want to get the measurements from the power supply first. So we do PSU, and you can see over here we've been prompted, we've got measure. What do we want to measure? The voltage. Which supply? Supply A. Very intuitive. And now it's prompting us that we want a var. That's a variable. That's where it will return the voltage that's been measured. So we will return that into V in, the voltage input. And we will do the PSU. Again, we will do a measure, and this time the current. Again, supply A. And again, you can see here it's prompting us for the variable long for the current. So that will be I in. I think I did capitals, but we'll soon find out. Okay, now we want the electronic load, and again we have measure, and we want to measure the, we'll do voltage first on load A, and we want to give it a variable. You can actually see down here it prompts you all of the variables available, so I could actually come in here and actually say this is the voltage out, which is here. I can actually use that instead of remembering what I've created as variables. Load measure, this time we want the current of load A, and we'll use this, so we got the I out. Okay, so now we've got all the measurements. So I think actually it's a good time to go and check whether I've got any errors. So I can click this button up here which says check all, tell me whether I've got any errors. It's not telling me I've got any errors, it's telling me I've got a couple of warnings that I haven't used P in and P out. That's fine, that's because I haven't yet. So I've got the measurements, now I want to do the calculations. So P in equals V in times V out. So P out equals V out times, oh, apologies. Yeah, no, that's correct. I out. So we've now calculated P in, and we've calculated, this is where my error, I knew I made an error somewhere. So P in is V in times I in, and then P out is V out times I out. Okay. Now we've captured all of the results. we can go ahead and turn off the power supply and electronic load. So we can go PSU supply set command supply A, and we can just turn off now. So that's going to turn it off immediately. Now we do the electronic load, the same for the electronic load. We will set command for supply A, or load A, apologies, and we will turn that off now. So now everything is turned off. We can make the result. Calculate result. So test result, which is a reserved word in ATEasy. This is what is outputted from the test, equals, and this is from the formula we looked at earlier, so that's going to be P out, that's the power out, divided by the power in, times by 100. And that's the test constructed. I'm just going to check whether I've made any errors. No, we've got no errors, no warnings. So what happens to that test result? If you know ATEasy, you'll know that we can come here, that's outputted to this particular dialog which checks the values going out. So we want to check the min and max. The unit is going to be percentage, and it should be between about 98% and let's say 93%. That's efficiency. So percentage of efficiency, and we can close that down. So when this value is outputted, that will be checked against these two min and max values. There's several average choices, you can do tolerance and etc., but here we just do min and max checking, and that's us done. So I think we now are ready to actually run. So we can come down from the top here, run start. Okay, that one's caught me by surprise, so I'm just I've got a runtime error, I'm going to ignore that. I'm just going to go up and have a look. We've got all of these errors that have come from the drivers. It's saying that we've had some communication failure, and I've just realized I've not even set up the actual communications for the system. So I can go down here to the driver. Again, this is an ATEasy Pacific task. I've got to go to the properties, I've got to set up the interface. As you see, I have no interface set up. I set up the WinSock. I have to put the IP number for the J-Testr, 192.168.1.101, and the remote port for that, that's actually the socket, but they call it the port, is 10002. So I will close that down. Now if we go up, we should have better luck. Okay, so down here we now see we have a result. We have a result of 91%. Here was our minimum limit of 89 and the maximum limit of 93. So obviously that is between the two, hence we have a pass. If we just go up a little bit, we can see that the task 1 was the efficiency test. We can see the result of the initialization of the motherboard, the result of the initialization of the low voltage supply card, and the load card initialization. Then it goes down, it executes the one and only test task that we have, which is the efficiency test. It says that it lasted a very small amount of minutes and that it's passed. So there we have it. We've written the test for an efficiency of a power supply, which is a fairly complicated test. We're obviously providing it with power, we're giving it a load, we're doing some voltage measurements and some current measurements, some mathematics to get the efficiency, and then we pass out the result to be compared with the predefined limits. So that ends this video. If you would like to know more information on the J-Testr and ATEasy, please contact ATEasy at jtestr@aigerdesign.com. I hope this video has been helpful. Goodbye.